Welcome to Mac 1140, Exam 3, Free Response number 3. In this question, they give you the following polynomial function, and they ask several questions. So the first question, they want you to go ahead and determine the leading degree and the leading coefficient of the polynomial. Well, that's just going to be whatever the highest power is. So the leading degree is going to be 5. So you'd say that this is degree 5. And there, for the leading coefficient, is going to be whatever the coefficient attached to that term is. This is known as the leading term. That's the leading degree, and this would be the leading coefficient. So the leading coefficient, which they just go ahead and call a sub n, is going to be equal to -1. And then they also ask you for the end behavior. So end behavior is essentially saying, what is this going off towards when x gets really, really big in the positive direction and really, really big in the negative direction? So you can think of x just going to infinity. So if x gets really, really big, all that matters is this front term here. And you can see that x to the 5th power is going to get really, really big as well. And then you have a negative out front. So basically, this is just going to be a really, really big negative number when you go off to negative infinity. So that means when you go off, when you go off to positive infinity, it's going to be a really big negative number. So that means when you go this direction, it's going to go down to negative infinity. So that's the one side. So if we go ahead and graph this, which eventually we will get to, so I'll mark the graph right here. We know as we go out this direction, it's going to go down to negative infinity. Now, what happens if we go to the negative infinity direction? Well, that means that you're going to have a big negative number inside here, and you're going to raise that to the 5th power, which is going to make it even bigger, but it's still going to retain that negativity. And then you're going to go ahead and hit it with another negative, and therefore make it positive. So that means when we go out to negative infinity this way, you're actually going up to positive infinity. So we know that when we draw the graph out, it has to have this end behavior. So that's it for part 1. Then part 2 says find the real zeros and multiplicity for each zero. So to find the zeros, you just go ahead and say, okay, what x can I plug in that makes this whole thing go to 0? So the best way to do that is to factor this polynomial part and set equal to 0 and solve it. So we can see that we can actually factor out a negative x cubed. So we could say negative x cubed. And then what we have left is this will go positive, and that's going to be x squared. This will go negative, and just a 1, because we factored out the x cubed. And you'd want to set that equal to 0. So then you can see, okay, when does this part go to 0, and when does this part go to 0? Well, this part goes to 0 at 0, so that's going to be one of your solutions. And this part's going to go to 0 at plus or minus 1. You can see that this is a difference of squares, and it can actually be factored apart into x plus 1, x minus 1. So you're going to get x equals plus or minus 1. So you actually have 3 different solutions. So now what we want to do is we go ahead and mark that on the graph here. 0, -1, and +1. We know those are all solutions. Now the multiplicities, that depends on what the powers are here. And you can actually see that this is raised to the 3rd power, so this has a multiplicity of 3. And if it's an odd multiplicity, it's going to actually cross through the graph. If it was an even multiplicity, it's just going to touch the, when I say cross through the graph, I meant cross through the x-axis. So if it's an odd multiplicity, it'll go right through, but if it's an even multiplicity, it'll just come down and touch, or come up and touch. It doesn't actually cross through. So all these actually have an odd multiplicity, because this has a multiplicity of 3, and then plus and minus 1, they both have a multiplicity of 1, because you can see that this x squared minus 1 breaks apart into x plus 1, x minus 1. And then that has a multiplicity of 1 and a multiplicity of 1. So since these are all odd multiplicities, you know they're all going to cross the x-axis. Now if we actually just wanted to attach a multiplicity, we'd say this is multiplicity 3, and these were multiplicity 1s. So that was it for part 2. And then finally, when they say sketch the polynomial, well, we have all the information that we need. Because we know that if it goes up like this and goes down like that at the ends of the function, and we have to cross these, basically we can just connect the dots. You go down, have to cross through here, we know we have to come back up and cross through here, and we know we have to come back down and cross through here. And therefore, that's what your graph should look like. You can go ahead and test it out, because if you know that this is 0 and like this is -1, choose -1/2 and plug it back up into the function. And you should get a negative value, because you know it lies below the x-axis. And you can do that with these other sections of the graph to confirm your answer. But, so, to conclude, this is a degree 5 polynomial. Its the leading coefficient is -1. Its zeros are 0, plus and minus 1, each of them with an odd multiplicity. X equals 0 has a multiplicity of 3. Meanwhile, plus or minus 1 has a multiplicity of 1. And this is the graph of your polynomial function.